So today we will be performing our first experiment where we will be practicing the basics of pipetting and understand how to perform dilutions. In many labs, you'll have to work with these instruments known as pipettors. And what makes them very useful is that they specialize in drawing up specific volumes of liquid. The problem is that they are also very delicate, so it's best to understand how to use them properly so that we can avoid any kind of damage. So on this rack, you can see I have 5 different pipettors. Starting on the left, we have this green pipetter that can draw up volumes from 1 ml to anything higher than 1 ml. And this number kind of is determined by the pipette that you attach to it. So the pipettes that usually are attached to the green ones, they kind of look like this. This is the one we'll be using for today's lab. It is a 10 ml serological pipette. And it can actually pick up volumes up to about 13 mLs accurately. So the set of pipettes to the right, or our blue pipettes, these are micropipettes. So these pipettes specialize in drawing up volumes anywhere from 1 ml to below 1 ml. So these micropipettes usually say somewhere on them the minimum and maximum volumes they can accurately pick up, with these specific pipettes saying them on the top. So right here. So here I have the P10, and you can see that when we look at it, it says we can draw up volumes from 1 ml to 1 microliter to 10 microliters, making it a great choice for when you're working with very small volumes. So when we want to kind of control the volume we want to pick up, all we have to do is really turn this dial. So as we turn the dial left or right, we can see that numbers on the back begin to kind of change, letting us know how much volume this pipetter will pick up when it's being used. So when we want to kind of read the numbers on the back, depending on the pipetter we use, the reading kind of changes a little bit. A good rule of thumb is to know that when you're reading the pipetter, the top number will always be the highest place value that the pipetter can carry. So since we're working with the P10, that means that the P10, the highest number, will be the tens place, then the ones place, and then the tenths place. And if you look really close to the tenths place, you can see these really tiny red lines. These would be the hundredths place. Meaning for this pipetter, if we were to use it, we can go and collect volumes such as 5.27 microliters accurately. Moving on to the next pipetter, we have the P20. So just like the P10, the top digit will be the tens place, then the ones place, then the tenths place, and then the hundredths place. So this is better if you want something a little bit higher than 10, but you're not really quite that high up in the hundreds, like the 100 microliter range. If we do want to reach something in the hundreds place, we will then use a P200. So here you can see that it collects volume anywhere from 20 to 200 microliters. And when we look at the back, we'll read it as the hundreds, the tens, the ones, and then these little black lines are our tenths place. So for this, we can collect volumes from 190 or 187.5 or 100. This is a very useful pipetter for us to use when we're in the very low range. Finally, if we want to go up to the higher ranges, the last pipetter we usually have is the P1000. So here you can see that the P1000 picks up liquid from 100 to 1000 microliters, or 1 ml. And when we read it on the back, we'll read it as the thousands place, the hundreds place, the tens place, and these little lines are the ones place. Meaning when we reach the P1000, we're no longer able to kind of collect volumes in the decimals. So now that we know how to control the volume, the next thing I want to kind of show you is how to actually use the pipettors. So when we draw volumes, what we'll mostly be using is this button here at the top. So you can see if I push it, I can push it down, and if I push it a little harder, it goes all the way down. So it's good to know these two different stops. So the first stop is when you push it and then you'll feel a little bit of resistance. So first, and then when you push it all the way down, that's the second stop. So the reason we need to know these stops is because when we push it all the way down and then release it, the vacuum will actually suck up the max volume the pipetter can hold. So because this is the P1000, if I push it all the way down to the second stop, then release, I'll pick up 1 ml. But I don't want 1 ml, I want 540 microliters. So instead, I'll push it down to the first stop and then release. So if I push it down to the first stop and then release, it'll only draw up that 540 microliters that I wanted to collect. And then when we dispense the volume, you go over wherever you want to dispense it and then push it all the way down to the second stop. And this will release any, liquid that you have in the pipetter. Finally, we have this button right here. And all this is used to do is to eject the tip that we attach to the pipetter. So you can see that each of these pipettors have different sized ends, which is a good way to kind of figure out what tip you need to use. It's normally pretty easy. The smaller the pipetter, the smaller the tip you're going to use. And so now that we have this information, we can start with the first part of the experiment, is where we practice using the pipetter. So what I'm going to do is fill up this empty Eppendorf tube with 4 different chemicals that you can kind of follow along in the lab manual. So here are the 4 different chemicals that I'm going to be using. The first is water, then glycerol, then ethanol, and finally acetonitrile. So in the lab manual, it says the first thing we're going to add is 539 microliters of water. So because this volume is higher than 200 but lower than 1 ml, the best one for us to use is the P1000. So here I've already set it to about 539. So here you can see on the tens place, or the hundreds place is 5, then the tens is, it looks like it's 4, but if you look really closely, the little triangle, the indicator, is a little bit below the 4. A little bit below the 4 and in between the other line. So each of these lines on the P1000 represent a digit of 2. So this would be 530. And if I go up these 5 lines, it's 532, 534, 536, 538. So in between 538 and 540, we have 539. So I'm going to attach a tip made for the P1000, which is our biggest tip. I'm going to open up our water. And while you may not be able to see it, maybe if I can adjust it a bit. Well, what I'm going to do is push down to the first stop, go into the water, release so that I can collect it. So here I am into the water. I push down to the first stop. You could see that by the air bubbles. And then when I release, I will have collected 539 microliters of water. I can then add it into my Eppendorf by pushing all the way down to the second stop, and this will release all liquid that was in the tip. So that is the first step. Next is the glycerol. So we'll be adding 233 microliters of glycerol. A useful tip when working with, I guess, the pipettors and picking up water is if you pick up water first, you can actually use the same tip and it shouldn't contaminate anything. So using the same tip, I'm going to actually pick up the glycerol. So because it says it wants 233, I'm going to change the dial. So here I'm at 230. I'm at 230. Going up each of those lines, 232, and then in between 233. So the problem with glycerol is that if you look at it, I don't know if you can tell, it's very viscous. It does not go or move very quickly. You can see it kind of sticks to the walls. So because of its viscosity, what I'm going to have to do is when I collect the glycerol, I'm going to push down to the first stop, go into the glycerol, and then release. And I'm just going to let my tip stay in the glycerol for maybe a couple seconds, 10 seconds or so, just to kind of assure that my pipetter is picking up the entire volume that I wanted to collect. So now I think I've given the pipetter enough time to collect the glycerol. I'm going to kind of wipe the tip to make sure that I don't take any excess glycerol. And then I'm going to add it into my Eppendorf. So because of the glycerol's viscosity, I'm actually going to pipette it very slowly. And you can see that, like, as I pipette it, the glycerol is kind of actually sticking to the walls of the tip. You see, like, how that glycerol is still kind of there on the tip. So a good way to kind of get all of it out is to put my tip into the solution and kind of just go up and down a little bit to kind of mix the solution a bit. This should make the glycerol a little bit less viscous and more easily to manipulate. So I'm just going up and down, repeatedly going to the first stop, not the second stop. So up and down, and now you can see that the solution is going much faster, kind of indicating that the solutions become less viscous. So now I've added the water and the glycerol, so the next step is to add the ethanol. So for the ethanol, it says we're going to be adding 143 microliters of ethanol. So the two options we have are to use the P1000, since it can go from 100 to 1000. So that definitely fits in the range. Or we could also use the P200, since this one goes from 20 to 200, which also fits that range. So because we've been using the P1000 for a while, I think what I'm going to do is use the P200 instead. So I'm going to kind of manipulate the value. So I need 143. So I'm going to turn this all the way up to 140. All right, so now here we are at 140. So because this is the ones place, I just have to keep going up. So 1, 2, 3. So this would be 143. So the P1000 tips are a little too big for the P200. So I'm going to find a different set of tips that should fit the P200 properly. So now that my P200 is ready, I'm going to open up the ethanol, go down to the first stop, draw up my 143 microliters of ethanol, and then put it into my Eppendorf. So finally, the last thing we need to do is add the acetonitrile. So for the acetonitrile, it says we need 27 microliters of acetonitrile. So our options could be to use the P20, but that's a little bit too low. So for this one, we're actually going to stick to the P200, since it can go from 20 to 200. So because we use this tip and it's dirty with a different chemical, we're just going to hit the eject button, and this should push off the tip so that it gets released. And I'm just going to dispose of it in this wastebasket. And now I can get another tip to measure out the acetonitrile. So the acetonitrile, we need 27 microliters. So I'm going to change this dial all the way back to 27. There we go. So here you can see the hundreds we have nothing, then the tens we have 2, and then in the ones we have 7, so 27. So I'm going to draw up 27 microliters by going down to the first stop, going into the solution, and then gently lifting up my finger to collect the 27 microliters. And now finally I'm going to add it into the Eppendorf. So if I've added the correct volumes of the 4 chemicals, we should have about 1 ml in this Eppendorf. So a good way to kind of tell if the measurements were accurate is to weigh the Eppendorf before and after to see if the mass, I guess, is equivalent to 1 ml or to 1 gram. So I've already measured the Eppendorf empty, and I'll provide that number as well as the mass with the volume to you guys so that you can write your lab report. All right, so for the next part of the experiment, we're going to be practicing our dilutions. And we'll be doing this by preparing 2 different buffers. The first will be TE buffer, and the second will be TAE buffer. And you can follow along with me in the lab manual on page 9. So to make a TAE buffer, or to make TE buffer, there are only 2, or I guess 3 components. The first is water, as well as tris and EDTA. So to make a proper TE buffer, we want to make sure that our buffer has a final concentration of 10 millimolar tris and 1 millimolar EDTA. So for us, we actually have made stocks of these chemicals. So here we have 0.5 millimolar, or 0.5 molar EDTA, or 500 millimolar EDTA, and 1 molar or 1,000 millimolar tris. So in order to dilute these stocks to their appropriate volume, we want to make sure that we understand how to use the formula M1V1 equals M2V2. So remember this formula, the M stands for concentration or molarity, and the V stands for volume. So the way we set up this formula is that we know our starting concentration of tris is 1,000 millimolar or 1 molar. We know that for tris we want it to be 10 millimolar, and we want to make a final volume of about 50 millimolar or 50 mLs total of buffer. So if I were to do M1V1 equals M2V2, I should get a volume of about 0.5 mLs or 500 microliters of our stock tris to add into this buffer, or to add into this volume. So next, let's make our TAE buffer. So here I have the 50x stock, and we've already calculated that we need about 10 mLs of the stock. So from here, I'm going to add 10 mLs into this granulated cylinder, where I've already measured out 490 mLs of water. So because the micropipettors are a bit too small in drawing up, I guess, 10 mLs of volume, now we're going to be using the green pipetter. So when working with the green pipetter, when we draw up liquid, it's fairly simple. All you're going to do is make sure to, I guess, open the pipette that you'll be using, and then here on the flat end, you'll connect it to the other end of the pipetter. And when you want to draw liquid, you can either gently roll this with your thumb. This will cause a vacuum and let the pipetter suck up the liquid. Or you can also just pull this little plunger up to draw up the 10 mLs. So I am going to do that first by opening up the pipette, connecting it to my green pipetter. So it should be secured. Let me open up my TAE. And I'm going to draw up 10 mLs, so up to this line right here. Kind of hard to see, but right here. I guess the end of this black line. So I'm going to gently turn the dial, and you can see that the liquid is slowly going up the pipette until eventually we have about 10 mLs. So now that we have 10 mLs, I'm going to add it into this cylinder by gently pushing the top all the way down so that the cylinder, or so that the volume can all get into the cylinder. So with that, the TAE buffer is pretty much done. All I'm going to do now is just pour it into this bottle so that I can use it for the next lab that you will see next week. So with that, we are done. And that will be the end of the very first lab.